All right, welcome to UBIC Bootcamp's Python Basics Makeup session. We are back, and we're going to cover for loop functions and do some fun um, problems that will help us see how do we use Python Basics in day-to-day bioinformatics lab activities. Now, this is where you should be right now. So you can find the link for the main notebook on the Google Drive, and you can create a copy of that and um, then scroll down to for loop part. All right. So for loop, what is a for loop? Or before even that, what is a loop, right? Loop, when we listen to a playlist on loop, we listen to the same song um, or the same song in the playlist again and again, right? In the same order. So that's what a for loop is too. You have a block of code that goes inside the for loop. That block of code is executed iteratively, um, repeatedly, right? So suppose we take this DNA sequence with A's and T's and C's and G's, and often what we want to do is not um, like, for example, find the GC count of a given sequence. So how many G's do we have and how many C's do we have? So th that task, I mean, that can be probably fulfilled by just using a GC calculator, but let's make a GC calculator basically. To do that, we have to look at each of these bases and keep track of how many G's we have seen and how many C's we have seen. So I'm going to go over each of these bases, right? And so on. Suppose I reach here. Now I know how many G's I've seen so far, and I know how many C's I've seen so far. If the next base is a C, I'm going to increase the counter of that C by 1. And if the next one is a G, then I'm going to increase the counter of G by 1, right? So that's essentially how loops work. Let's see it in action to get a better feel of it. So the sequence is defined again, okay. Now G count is just 0. So in this loop, we're counting just the G's, okay. So G count is a 0. That's just how I've initialized a variable. G count will keep track of, as I keep iterating, right, or going over all these bases one by one, I need to keep track of how many G's I've seen, and that's what the G count variable will do. As I keep iterating, I will keep changing the value of G count by increasing it by 1 if I see a G. Okay, so let's delete this code and form our own code, right? So what if we don't even start with the for loop? We just first make the code to see if a given character, C maybe, is a G, right? So let's make an if-else statement to increase G count by 1 if we see a G, and that's it, yeah. So for that, we'll say if, and then we have the condition. So if the character that we have, so maybe that is just char, if that equals G, right? What do? We increase G count by 1. So we increment it by 1. We use the augmented assignment, and we increment it by 1. That's the if condition. But of course, I don't want to do it on one particular character. In fact, I don't even have character defined here yet. I'm going to do that as I go over each character in this entire sequence. All right. And I'm gonna, so how it works in for loops is whatever's inside of the for loop needs to be indexed, needs to have an extra index. So I'm shifting that by a tab key. That's the same as how I would do an if statement as well. Whatever's inside the if statement has to be, if it's in the next line, it has to be indexed by an extra tab. All right. Okay, now whatever's outside of this block of code, so whatever's outside of this indexed block of code will be outside the for loop. So that part will be executed after we have gone through the entire for loop. So if I write something, print hi, right? This is my for loop. I'm not concerned about what I have right now, what I'm doing here, what I'm getting here. Let's just run this first. Invalid syntax. Oh, sorry. Yeah. So it prints hi once, and that's at the end of the for loop. If I put something inside the for loop that is just indexed by a tab, so now this whole thing is a block of code. So now it's gonna print hi for every base, for every character in the sequence, it's gonna print a hi. So just by a tab, I'm defining when something should be implemented. So when something should be executed. All right, so instead of printing hi, I'm gonna print g count after I'm done going over this for loop. Okay, let's do that. So 15, and yeah, so there are 15 Gs in the sequence. So 15 times as we go over this base, we see the character equaling to a G, and we hence increase the G count 15 times. And you can see it in action. If I just give it a tab, it's gonna print as it sees each base. So it first sees, so it sees a C, G count is 0. A, the G count is 0. It sees a G now, so the G count increases by 1. Now then it sees sees a C, so the G count will not increase, right? Because we won't enter this if condition. And the G count is still at 1. And then it stays at 1. Then it increases by 1, so it becomes 2, 2, 2, and then it increases by 1, so it becomes 3. Then it stays the same because it's not a G, and then it becomes, and so on. Keeps increasing like that. So you can see for each base, our value is increasing, and the last base actually increased the value of G count by 1. So last base must be a G, right? So that's how for loops work. Syntactically, they are not very hard to understand, but it can be a bit confusing if your indentation is a bit off, or like if you can't find what's not indented properly. Yeah, so be mindful of that. Yeah, that's it. Now, another way to write a for loop is to use a list comprehension. What a list comprehension is if you've seen set builder notation of sets in math, it's very similar to this. So we say for character in seek, same as this for loop, we make a list. Okay, so this is a list. The right part of that list is defining a kind of a for loop. Okay, and here we'll define what that list should contain for each character. Suppose I say just character. Simple. So for each character in sequence, put a character in this list. So it'll give you a list of each of the character in this string, right? Now, if I say, like character multiplied by 3, for example, then it'll give me each of those characters multiplied by 3. So I can apply something to each character by just defining what I want here in that list, right? And not only does it, and it doesn't even have to be an element essentially. So what I've done in the cell below is I first gotten a list of just the G's, right? And how that works is that just like how I can put the for loop here, I can also put an if statement after that. So a condition for this for loop. So I'm going to say character, but only if that character is a G. Now it'll contain only those characters that are equal to G, right? So I'm going over all the characters in the sequence. I'm checking if it's a G, then I'm putting in the list. Number of G's in the sequence would be the same as length of this list, because that's how many times a G has appeared in the sequence. So if I say length of this list, I'm going to get my G count, which is 15. Yeah, and that's what I've done here. I've made a list called G's, and then I printed the length of that list. And in fact, there's also a method called count. So in a string, seek, for example, I can say seek.count G. So that'll give me the count of G. So that is definitely the most optimal solution, I guess, but it's important to understand. I was just using this as an example, but I also want to make you aware of this function count that you should actually use in practice and not this for loop. Usually you would use the count function, if you want to. All right. So that was for loops. Before we get into this test file and stuff, um, I do want to go over defining functions as well. What's the time? Okay, we have time. Right. So, okay, let's just run this actually. So running this will give you the test file that we want. And this will just list all the files that are present, and you should see test.fasta here. And if you run this, this is a for loop. So file here is what this open function returns. The open function takes test.fasta as its first argument, then R, which means read. Don't worry about the very details of this. You'll see this, and we can talk about this more even. But basically, this open function returns what's called a file handler, and this file has many lines, right? So we can say for line in file. So now it's iterating over each line in this test.fasta file. If that file starts with greater than symbol, then that is what do you call a sequence header, a header identifier, or a sequence ID basically. And for that heading, we're going to just print that heading. So for each line, if the line starts with this symbol, then I'm going to print it. If it does not, then nothing will happen. So this way I get all the headers in my test.fasta file, and that can be useful, right? For example, maybe I have to do something with those headers. Maybe I just have to give this information to someone. Oh, these are all the sequences that I have. Maybe I have to make a report or something. So yeah, that's a useful case of using for loops, right? That's another way to do it using list comprehensions. As I told you, you don't really have to like print line will basically return a none object. So this list will actually be a list containing none values. None is something that does not have a type. None is just nothing, essentially. No string, not a number, it's nothing. It's just an object, it's none, basically. Similar to null in Java. Okay, so since these are all nones, I don't really need this list. I'm just calling this list by a name called underscore. That's just a convention. If I don't need to like really get a variable's name or like assign its value to something, I can just say underscore equals that. You can do anything. You can set it as like a useless list even, and just have this list comprehension actually print the lines. So this will print the lines, and I have a new variable that I don't need. That's okay. Okay. All right, now let's come to functions. Actually, yeah, before we move to functions, do you have any questions on for loop, list comprehensions? And I know they're a bit, the list comprehensions especially might be a new concept, but as you get used to them, they'll become like, you'll see the power in using list comprehensions as opposed to for loops. I think like really helps you if your lines of code are just one-liners, or you just find that cool and become used to it. Um, so yeah, we'll use those for loops and list comprehensions in the exercises that follow. Um, just one more Python basic, functions. Function is basically something you can um, use to like define a particular block of code on a given input, um, so that you can carry out that code whenever you want on different inputs. So for example, I think the basic function could be just print. Print is a function. If I say print, it says function print. It's a function because when I give it some input, which is always given in parentheses, if I give it some string as input, it prints the characters in that sequence. Or if I say a number, it prints the string representation of that number. So print is a function. It takes in argument, and then it prints that value. It doesn't need to have inputs always. A function can be empty, like a function can have no arguments, a no arg function, um, such as um, maybe just help function. Is that a function? Yeah, and that help function is saying welcome to Python and stuff, and it's doing that every time. It does not take any inputs. It's just there. We can stop it. Oh, right, right. So let's say I have a string seq1, and this is a short DNA sequence. The count of, like, here count is also a function, but what's different about it is that it's a function defined on seq1. So count can be used with any string, but you'll have to use it with that string and then say dot and then call that function. So seq1 is essentially actually the first argument of count function, and the second argument would be these arguments. Length is another function that you've seen. So this is a simple string function, length of seq1. Okay, I have to first define seq1. So length of seq1 is simple, right? We're not calling it on a particular string as such. It's not a class-based function basically. The first argument is actually in the brackets, and that's seq1, and it just returns the length of that string. But if I wanted to get the count in that string, then I'm gonna say seq1.count. Okay, I didn't give any argument. But it does need some arguments, so maybe q. And it has to be defined on a particular object. So in a way, it's taking this as its first argument, but it's not technically an argument. But it does need like an input. Oh, it does need an input here. Yeah, so it'll apply this function on this object. It's a class-defined function. For example, if I run this, it's a function defined in the string class, right? And it'll apply on any string object. I could even say, instead of seq1, I could even say a string and then dot count and say, hey, or q and 0. Right. Another string function is upper and lower functions that just converts given string into lowercase and uppercase. If I had if I have a mix of uppercase and lowercase characters, I can get just upper characters. I can get just lower characters. Yeah. So as an example, let's we know how to get the G count and the C count, and we know how to add them and get the GC ratio, which is basically the ratio of number of G's and C's combined, and the length of that string, the total number of characters. So the GC ratio, by the way, is the number of G's or C's okay, divided by the total number of characters, the length, i.e. length, right? So instead of printing this here, if I have to get now the GC ratio of a different sequence, so I'll have to call this thing again for that. Like if I have a seq2 with a different sequence, I'll have to do this thing again. So instead of doing that, I can define a function that takes a seq as an argument, and then I can return a value. Return a value basically re returns that like um, allows you to use the value that is the output of that function. So if I had to get GC content of seq1, which is defined here, right? It'll give me the GC content in that sequence. Syntax of a function starts with a def, then the name of the function, then the arguments of that function, and then a colon. Inside this, I can do anything I want. Print stuff, or I can do like x equals 4, x plus equals 2, and then print x. Once I call this function, it'll do everything that's inside of that function. So if I run this, if I define GC content as this now, and then I run this, it'll print stuff. It'll print the value of the string x, I guess. I want to print this, sorry, print x. So it prints x as 6, and then it returns, however, now it's not printing, it's returning the value, this, the GC ratio. Now I can even like get GC content of different strings. Right, so it's gonna call this function 3 times, so that's why we're printing these stuff. Returning does not print the value, so we get stuff, then we get 6, and then it puts that value here. It puts the value returned here. Okay. Then it calls GC content again, so stuff, then 6, and then it returns that value here. Same thing again. It prints 6, it prints stuff, it prints 6, and then puts the value, the GC content ratio, here. And then the output of this whole thing becomes a tuple, which is similar to a list, containing each of those 3 values. And I can even check, and I can even give the arguments using the name of the parameter here. Difference between argument and parameter is that when I'm defining something, this is called a parameter. And when I'm actually giving something, it's called an argument. So the value that I'm giving is the argument, and the label that kind of helps me define the function for given arguments, those are called parameters. So I could say this parameter, seq parameter, is seq1 argument, and that'll do the same thing. By default, it takes the value of the different arguments in order. So now with this function, I can easily call, I can easily get the max GC content in these different strings, right? Yeah, and so if I had to get the like max GC content of 3 strings, these 3 strings, right? I could say max of GC content of this, GC content of this, GC content of this. And if I wanted to, and I can again use it in even if-else statements, I can say if GC content of a given sequence is more than 0.6, then say hi GC. And if it's not, print the actual GC. So here the GC content is 0.5 because 2 of them are GCs and there are 4 bases here. So we'll print 0.5. If this was containing another G, then it'll become 3 by 5, which is still 0.6. If it contains another GC, then this will become now 4 by 6. So that is 0.667, so greater than 0.6. If I print that, it'll print high GC. And as you can see, since I'm calling this function thrice here, 4 and then 5. So in total, well, actually not here, since I went to this branch and not this branch. 3 times here and then 1 time here. Since I'm calling this 4 times, it'll print stuff 6 4 times. So it's printing 3 times for this line, and then once for the if else statement. But if my GC content was lower and it actually went here, then it'll print stuff 6 again for this call. So 1 and then 2. Okay. Right. All right, it's 12:20. Any questions? All righty. Then here's a task for you. Here's a challenge for you. So now that you've learned for loops, if statements, functions, and different stuff like that, and even list comprehensions, you have so many ways to do the same task now. So you can fulfill this task using different ways. You can explore different ways to do this. What I want you to do is, or I guess what your lab PI wants you to do actually, is get the first word in the header. All right. So get the first word in the header and then get the GC content. So you need a table essentially, kind of like a table, or I guess 2 columns basically. You need the name, the first word in the header, and then the GC content of that sequence. So this kind of a table is what you need. You want this for the whole sequence. I'm printing just the 4 lines, first 4 lines here, but you want the entire table. For each sequence in that file, you want the first word in the header and then the GC content, right? So you can definitely use the GC content function that we've defined here. And what you might find helpful is also the for loop that we use to get each line starting with this greater than symbol, each header in that sequence file. So these 2 things could be pretty useful. And yeah, so have fun. And let's see, you can do this using for loop, of course. You can do this using comprehensions, and yeah, whatever way you want to do it, you can explore different ways. Right, let's get started. And feel free to just unmute yourself if you have any questions. And I'm going to stop the recording here. Thank you so much for coming to the lesson.